Hi everyone, we will continue chapter 8 second part. First part, you learn if we are sending any light, how it can be refraction. Today we will draw or we will find the image location or how we can drawing the image. Firstly, image formation by the lenses. To form an image, at least two rays from the same point must be intersected after the refractions. Firstly, convergent lens. If object is at infinity, how we can draw it or how we can find the position or location of the image. Firstly, we are sending the some ray. This ray it is coming parallel to principal axis. You know, if any light comes parallel to principal axis, it will be refract and passing on the focus point. If object infinity, all rays comes parallel to principal axis and refractions, all of them is passing on the focus point. We can say image, a point, and position is on the focus point. Secondly, if objects on the center point, you know why we are writing the one side is 2f, one side is c. If you remember, from mirror lenses to focus point, if you say f, and this part is also equals, center point location is 2f. Now, objects behind the center point, it means from this side. Objects behind the center point. Firstly, we are sending some spatial rays. Firstly, spatial rays comes parallel to principal axis. Refractions, it is passing on the focus point. And this is first light ray. Secondly, we sending on the optical center. You know, if any light ray connected to the optical center, it is passing directly. Look at this. Two refractions connected point is connected between the focus point to center point. Now we can draw image. Now we will describe about the image. Firstly, is normally two light rays that enough, but we are sending also three rays. Look at this. If any light ray it is passing on the focus point, refractions going to parallel to principal axis. Look at this. Three refraction ray connected same point. Describe the image. Image is between the center point to focus point, and image inverted and dimension is meaning smaller than objects, and image is real. Inverted is meaning the shape is opposite. And if object at center point or on the 2f. Also, we are sending the same light rays. Firstly, it is passing on the focus point parallel to principal axis. Then it is refraction on the focus point. Second ray, it is connected to the optical center. If you connect to the optical center, it is passing directly. It is not curving. And we are sending the third light ray, or is normally 2 rays is enough. if we are sending third ray, it is passing on the focus point. If we're passing on the focus point, it is moving the parallel the principal axis. Information of the image position at the center point, and image is inverted, and the size is equals, and image is real. And another one is objects between center point to focus point. Objects between the center point to focus point. We are using the same way. First, we are sending the first ray. It is parallel to the principal axis. It is passing on the focus point. Second ray, it is connected to the optical center, and refractions, it is moving directly. And when the connected point, we are drawing the position of the image. Look at this, the size of image and size of objects when we are comparing. First, the image behind the center point and image inverted but magnified, its meaning larger, bigger than objects. And image is real. And last one, if objects at the focus point, if you remember, opposite of the first rules. If objects on the focus point, the position of the image. Try yourself. Firstly, you will send two rays. Firstly, parallel to principal axis. Second, on the optical center. Let me solve. We send first ray parallel to principal axis. It is passing on the focus point. Secondly, we are sending on the optical center. If you connect it on the optical center, it will be passing directly. Look at this. These two refraction light, it is parallel. If any light or any light rays moving there with the parallel, they are not connected any place. If they are not connected any place, we can say image is at infinity. And until this part, or first 1, 2, 3, and 4 part, image, all of them is real. But this one is if objects between the focus point to mirror. Focus point to mirror. Look at this. We are sending the same ray. First ray parallel to principal axis. Secondly, connected the optical center, and we will draw connected point. Firstly, passing. Secondly, on the optical center, it is passing. Look at this. These two refraction light is not parallel. If it's not parallel, we will draw extended light. Look at this, extended light. But extended light, it is connect each other. If extended light connect each others, we can say about the image. Look at this, image and object same side. First thing, image behind the mirror, both of them is same plane, Secondly, image is erect. Erect is meaning the size is same, looking the same side, and magnified. Image is bigger than objects, and virtual, it means not real. Now we will drawing the same rules on the divergent lens or concave lens. Firstly, if object is at infinity, we are sending the same ray passing parallel to principal axis, and we are drawing extended light. Look at this. All of them is extended light passing and connected on the focus point. We can say image behind at the mirror, erect, dimension, and virtual. Secondly, object is close enough to lenses. First, we are sending same ray. We draw the extended light. Secondly, we send the one ray. It is extended light. It's passing on the focus point, and it is reflect and moving the parallel principal axis. And we are extended light connect each other. Extended light connect each other when the connected point it is position of the image. Image behind the mirror, erect, dimension smaller than objects, and virtual. Example. The figure below the showing an object which is placed at the distance of 2f, it's meaning center point, from the convergent lenses. Firstly, where is the image format? Image format, for example, first I am drawing the position of the objects, then I am starting sending the ray. First, I am sending 2 ray, and just a minute. Secondly, connected on the optical center. Firstly, it is refractions. It is passing on the focus point, and secondly, it is passing on the focus point. Image is if on the center point, object position and image position, it is on the center point, but opposite side. And second, list the image properties. If you remember, if image and object is on the center point, we can say image and object, it is same side, and both of them is on the center point but opposite side, and real. The image is real, upright or erect, and the same side on the objects. Law of the lens and magnification. Laws of lens and magnification. Firstly, when we are drawing the one system about the lenses, firstly I draw one object and one lens and optical center. Firstly, if one object on the after the focus point image is we draw, firstly we can say the size of objects, we can say h, and size of the image h power, and the object side on the focus point we can say capital F, and another side or image side on the focus point we can show F power, and between the focus point to optical center we can say F or focal length, and between the object to mirror we can say U, and between the image to lenses we can say V. And if you know this one is, we will using the position or focal length or the size of the objects or the size of the image we can find by using equations. Object distance from the lens U, image distance from the lens is V, and length of the image h power, length of the objects its name h, and from the lens and the focal point is called focal point we can show F. Our equations similar to mirror, 1 over focal length equals 1 over object distance from the lens plus 1 over image distance from the lenses, or 1 over F equals 1 over U plus 1 over V. And it's worth to mention that this law is general law of lens and mirror. Same laws of the lens and mirror. While the magnification laws we can show capital M for lens is given by magnification equals length of the image over length of the objects equals image negative minus image distance from the lens V over object distance from the lens or U. Be carefully. It is negatives when we are using distance. The general law of lens is applied to whether the lens is convex or concave with the Gerard to the sign of each quantity when the light incidence of the lens move from left to right as following. Firstly, the object distance U is positive if the object was relocated on the left of the lens, taking negative side if the object was located on the right of the lens. Look at this. If object was relocated and the right side of the lenses, it is positive. Secondly, the image distance is positive if the image was real and located on the right side. If image was real and located on the right side of lenses, and takes negative if, carefully, if the image was virtual located on the left of the lenses. Another one is the focal length is positive for convergent lens or convex lens, and carefully, it is positive convex lens or convergent. and negative sign for divergent or concave lenses. And the length of the erect, its meaning upward, have positive sign, and the length of the inverted upward positive, and the length of the inverted object downward have negative sign. The length of the erect image, its meaning upward, have the positive, and the length of the inverted image, it is downward, have negative sign. And for the magnification sign, and for the magnification M sign. If magnification equals positive, the image is virtual, and erect according to objects. When the magnification is negative, the image is real and inverted. Its meaning, opposite meaning the property of the positive magnification. The value of magnification tells us the following. If magnification bigger than 1, then the image is magnified according to the objects. Secondly, if magnification smaller than 1, then the image is minimized, smaller, according to objects. If magnification equals 1, then the image is equal to object. Its meaning, both of them is on the center point. The ratio between the two areas of the image and the object equals to the ratio between the square of distance from the optical center of lenses. We can find, or we can follow the equation, area of the image over area of the object equals image distance from the lens power 2 or square over object distance from the lens square.